Okay, now we will do this problem. Let B be the set of continuous, let B be the set of continuous real function. Let B be the set of continuous real functions f on 0, 1, for which 0 to 1 fx dx equal to 0. So your question is, so that the set of f for which 0 to 1 x fx dx equal to 0 is a subspace. Second part is the set of f in V such that 0 to 1 x minus fx dx equal to 0 is a subspace of B. Okay, this one a subspace of B. They asked this question. Okay, you want to check whether this is a subspace or not, and you want to say that this one is a subspace. Okay, these two questions now we will do. Okay. So for first part, let alpha comma beta belong to real number f comma g in V. Therefore f and g are continuous functions. They asked to prove that this one, for f function f, this one 0 to 1 x fx dx, this one equal to 0. For any function this condition is satisfying, then this one belong to W. First, you want to show that this non-empty set, because W is non-empty, because here your function, I think here you take this f of x equal to 0 function, okay? F of x equal to 0, then you can get here integral also 0, okay? 0 function. Now you take this one, 0 to 1 alpha f plus beta g x dx. Your claim is you want to show that this one equal to 0. This integral is equal to 0. So this integral is 0 to 1 alpha f of x beta g of x dx. So it is alpha times 0 to 1 f of x dx, beta times 0 to 1 e of x dx. So it is alpha times 0, beta times 0, because f and g are belong to W. Therefore, this should satisfying this condition. So, yeah, here, sorry, here mistake, x there. So x f x, so x e x, don't worry. So this one 0, no? This one also 0 because this constituents which specifying there this one 0, this one 0. Therefore, this one 0. This one 0 means this alpha f beta g, this one belong to W. Okay, alpha f beta g belong to W. Therefore, W is a subspace of B. W is a subspace of B. Okay, W is a subspace of B. Subspace of B. Okay, W is a subspace of B. Okay, next B part. Okay, so for B part now. For B part, for B part, uh, you consider this set, okay? B. W is given one for a function f integral 0 to 1 x minus fx dx. check whether is follow the subspace or not. So you take let f of x equal x, then g of x equal minus 3x minus 1. Both are continuous, okay? And also, what about this mid value, 0 to 1, integral values, x minus x dx. So we say 0, no? And what about this integral value, 0 to 1, this one, x minus 3x plus 1 dx. So it is 0 to 1 minus 2x plus 1 dx. So it is minus a squared by 2 plus x 0 to 1. I think you get minus 1 plus 1, then you get 0. Therefore, this integral value is 0, this integral value is 0. Therefore, this both, that means, therefore, f comma g belong to W, right? Suppose this is subspace, you take two scalar, alpha and beta, let alpha comma beta belong to real, and already know that f comma g belong to W, then you check this condition, no? You check this condition. X, this one, x minus your f is alpha f plus beta g dx, dx. Okay. For any values of alpha beta, okay, for any values of alpha beta, right, for any values of alpha beta, this integral is 0, this integral is 0, then it is a subspace. Therefore, you can use some values for alpha. I use alpha 1, beta 2, f and g is given 1, no? Then what is the integral? X minus alpha 1. Therefore, f is x, no? Beta is 2 times minus 3x minus 1. Minus 3x minus 1. So, dx. So, what is this one? 0 to x, x minus x, minus, again minus 6x, minus plus 2 dx. So this is cancelled. Then 0 to 1, 6x plus 2. So what is the integral? 6x squared by 2, 2x 0 to 1. So it's 3. 3x squared plus 2x 0 to 1. I think this integral is 5, not equal to 0. Therefore, for at least for these values, this integral is not equal to 0. Arbitrarily, you can take two values, alpha and beta. This condition is not satisfying. Therefore, W is not a subspace. Okay, W is not a subspace. Okay, therefore, W is not a subspace. Okay, W is not a subspace. Okay, right. W is not a subspace. Okay. Now next question. Let v1 is 0, 1. v2 another vector 1, 1. And define two sets. And define two sets. It's w1 first. It is t v1, t belong to real. And w2 another set, t v2, t belong to real. Also let v equal r squared or at pairs over real with standard operations. With operations. First question is, so that W1 and W2 are subspace of B. B part, so that W1 direct sum of W2. For first part, so as W1 and W2 are subset of B, is it okay? And B is a vector space, okay? B is a vector space, is a subset, therefore it's also a vector space, therefore which itself is a vector space, which itself is a vector space. Okay, first you consider this W1. W1 take the values of the form T v1 T belong to real. Okay, then you want to show that W1 is a subspace. Obviously, for put T real number, no, 0 times V1, it is 0. This one belong to W1, therefore non-empty. Therefore non-empty. Now you take two vectors s comma y belong to W1. Therefore, there exists t comma s belong to R such that x equal t v1, y equal t v s v1. Okay, s comma t real number such that s equal t v1, y equal s v1. So what about x plus y? X plus y equal t times v1 s times v1. So you can use the distributive law. Then you will write s t plus s into v1. This is element of w1. Okay. For next condition, let x belong to real number. X belong to w1, and you take one of the scalar a. A belong to real number. Okay. A belong to real number. So a belong to real number. So from this one we will write, what about this ax? Ax equal a times x is t1v like previous. X is t1v. So this is t1v now. Then we will write this at1 times v. Sorry, atv1. Sorry. Therefore at times at into v1. So this is of the form in w1. Okay. Therefore W1 is a subspace of V. Therefore, W1 is a subspace of V. Similarly, W2 is also a subspace of V. Subspace of V. Similarly, okay. Similarly, W2 is also subspace of V. Next question, they asked to prove that V equal W1 direct sum W2. It is not difficult, right? This question, you ask two things. Suppose V equal direct sum of W1 plus W2 means you want to show that W1 intersection W2 is singleton zero element, only consists singleton zero element. And another condition, W1 plus W2 equal V. You take one of the element W1 set, another element W2 set, add these two elements, you get the set element in this V, in V. Okay, these two things you want to show that. Okay, just this type of proof. Okay, it's called as a direct sum. Okay. Now we will prove first one. Therefore, you take one of the arbitrary element in the set, this one, W1 intersection W2. You take one of the arbitrary element first. You take one of the arbitrary element first. Let x belong to W1 intersection W2. Our claim is you want to show that x equal to 0. Okay, x equal to 0. So x belong to W1 intersection W2 means Then for some t comma s belong to real, right? T comma x belong to real. We have, because x belong to w1 and x belong to w2, no? Therefore, s t comma s belong to real number. We have, okay, we have x equal t times v1, okay, and similarly this again x equal s times v2, okay, s times v2, but both are x, therefore t v1 equal s v2, okay, t v1 equal s v2. What is the v1 values? V1 is given 1, 0 comma 1. What is the v2? 1 comma 1, s times 1 comma 1. Therefore, this both are equal means the coordinate wise the elements are equal. First element is 0, here s. Is it okay? S. Second one is here t, here s. Therefore, ts, but s is 0, no? Therefore, t also 0, right? T also 0. Therefore, t 0 and s, t 0, s 0. Therefore, x equal to 0. Therefore, the element is 0, right? Therefore, x must be 0, okay? X must be 0 vector. Is it okay? Therefore, W1 intersection W2 is only consists singleton 0. Okay? It is first claim we proved. For next claim, right, this one you want to prove. For this, you take an arbitrary element, let a comma b in R squared. Order pair, no? A comma b in R squared. Right? We want to show that okay, we want to show that x equal to w1 plus w2, okay, it is your x equal w1 plus w2, right? For some w1 belong to capital W1 and W2 belong to capital W2. Okay. Now by setting, right? Now by setting, you take W1, okay, ordered pair 0 comma B minus A, and W2 ordered pair A comma A. This accomplish this as Wi belong to capital Wi means for W1 and W2, okay, this accomplish, okay, A comma A, okay, from this accomplish, I will write here. So we have here, we have, I can write here, this one accomplish, okay, accomplish that, which one? Accomplish this, which this condition, okay, accomplish this, Wi belong to capital Wi. For W1, small W1 belong to small W1 belong to capital W1 and small W2 belong to capital W2. Okay, for I1, 2. Okay, for I1, 2. So W1 plus W2 is, right, of the form, you can add this both, no? 0 comma B minus A comma A. So we will get A, B. But A, B means belong to R squared. Right, A, B means here belong to R squared. Here V means R squared, no? V equal R squared, no? So, right, this one equal to this one, therefore this one belong to, this one belong to, that means here W1 plus W2 also belong to R squared, no? This one belong to R squared. That means capital W1 plus capital W2 subset of R squared. So obviously this one is satisfying R squared subset of W1 plus W2. Right. Therefore, you can write B means R squared equal W1 plus W2 Drexel. Okay.